Hello students, now class 11th I told you about the simple harmonic motion, and today I will take the simple harmonic motion, the motion of the projection in circular motion. Motion of projection in circular motion. So let's we are having a particle P is moving along perimeter of a circle of radius a. With angular velocity omega. So we say that this is the circle, this is the center, this is the point A, B, C and D. This is the particle P and it is moving along this perimeter, and this is the angle theta. The projection of P on BD axis or the BD diameter this is suppose N, and in AC diameter this is M. So this angle is also theta. The angle AOP equal to angle OPN equal to theta, and this is equal to omega t by definition. PN is perpendicular foot of particle P. So now we have to see that when this P moves from A to B, B to C, C to D and D to A, then how does this foot of the perpendicular moves? So the N is the foot of the perpendicular. N equal to foot of perpendicular. So we start from A. Number 1, when particle P is at point A, the starting point. The N will be at center O. Second, motion from A to B. The N will move along OB at B. The particle P and foot N coincide at this B. The P and N will coincide. And now third, motion from B to C. The foot will move and move back. It means BO, along BO. So at C, now put N will be at center O. This is from B to C, then C to D. Fourth, motion from C to D. The foot N will move along O, along OD, and at D, the particle P and foot N will coincide. And now fifth, motion D to A. The foot N will move back, that means DO. So at A, the foot N will be at center O. Now this one observation is complete. Thus one cycle is complete. And we see that in one cycle, the foot N moves along the diameter BD. In this circular motion of particle P, the foot N moves along diameter BD with O as main position. With center O as main position. Since particle P is moving with constant speed, so the foot N will have periodic motion. The particle, the foot N, is moving along a straight line, so this is the simple harmonic motion of the foot. The foot N moves along a straight line. BD. So its motion is SHM. Now we take this particle P will move continuously, so the foot N will repeat the center O at a constant interval of time. Thus foot N will repeat center O with constant interval of time. So I told you that we let O N equal to Y. Then from right angle triangle, right angle triangle OPN sin theta equal to ON upon OP. So ON is equal to OP sin theta. ON equal to Y, OP is equal to A, and this is equal to sin theta. So ON A sin theta. It is the equation of displacement for SHM. Now similarly, for put M on diameter AC, we can have x equal to A cos theta. So all these terms show that here the displacement, if we take this y, then this is now A sin theta. If we take x, then this is now A cos theta. So all these are the periodic functions of theta. So this either we have this sine or we have cos, they always show the simple harmonic motion. So all those equations which are the periodic function of the angle, sine or cos, they always show the simple harmonic motion of the particle. So this we have assumed that initially the particle was at O. That means was at O. So this was coinciding with the origin. If suppose the particle is not initially at A, in this discussion, we have assumed that initially the particle P is at point A. Now if suppose the particle is not at A, then what will happen at that time? Let initial angular position of particle P is at P0 with angle phi. It means what? That suppose we have taken like this. This is the circle. This is now O. This is A, B, C, D. the particle is moving like this, and now particle is supposed at this point. Initially this is at this point P naught. This is an angle of phi. Now particle starts the motion from P naught. Then it reaches at the point P, such that this angle is theta. So theta, this is equal to omega t. Now total angle will be how much? Initially angle AO P naught equal to phi, and angle P naught OP is equal to theta equal to omega t. So the total angle is how much? Total angle is equal to theta plus phi. So this is equal to omega t plus phi. So what? That in these equations where we are having this sin theta, cos theta, we can also write them to be like this one. So this is, we can write this y is equal to a sin omega t, and this x equal to a cos omega t. Therefore omega t, therefore displacement equation this is now your y equal to a sin omega t plus phi, or x equal to a cos omega t plus phi. So these will be the displacement equations. So if we assume that the particle is initially at the point O, P naught, then this angle is phi, and after time t reaches to the point P, then it makes the angle theta omega t with the initial position. This is so much, then total angle will be theta plus phi, because angle is always measured from OA, the x direction. This is now point A, this is direction x, this is point B, this is now direction y. So direction of the angle is always taken from x, because it is moving anti-clockwise, and if it is moving clockwise, even we will have to take the same equations. So there will be a difference of minus only, then remaining will be the same. So the angular position of the particle is always measured from x direction. The angular position of particle is measured from x-axis. Thus shown here, this is the x-axis, this is y-axis, this is the origin O. So thus we have the displacement equations, and this is the motion of projection in the circular motion. So you all like, subscribe and share this video, and also tell it to your friends who are studying in class 11th. Thank you.